This lesson is on section 2.4, which I have split up into 2 days. Today we are going to concentrate on the properties, postulates, and being able to just justify an answer. In your other math classes, when you've done step-by-step problems, you've simply done that. You've gone step-by-step and solved a problem. Now that you are starting to get into upper level classes, we have to start looking at why. Why can you solve problems the way that you do? Why can you add 4 to both sides? Why can you divide by -3 on each side? Why is it okay to do the things that you're doing instead of just simply doing them, looking into why? So some of the properties, definitions, postulates, theorems, some of the stuff that you've already studied and some of the stuff that we're going to study is going to come together now. So for example, when you have a problem, an algebra problem, for example, that's just a second, my stuff doesn't want to work here. Let's try. Technology is a wondrous thing. Okay, so let's say you have like 3x plus 4 equals 17. Okay. Now in algebra, you learned that you needed to subtract 4 and then divide by 3. In geometry now, we're going to be doing those same things, but we're going to add a second level. And the second level is, yes, I'm doing this, but you have to be able to say why it's okay that you're doing this. Okay? You have to be able to justify each of your answers. Properties is one way that you can do that. Okay? For example, the addition property. The addition property says if you have 2 things that are set equal to each other, for example this, the 3x plus 4 is set equal to the 17. Then the addition property says it's okay to add the same thing to both sides. As long as you add it to both sides, it's an okay thing to do. So I could add -4 to both sides. I could add, 7 to both sides too, but adding 7 wouldn't get me anywhere. If I added -4 to both sides, that would cross out the +4 and it would make the problem more simple. The addition property just simply says you can add the same thing to both sides. These all work the same way. The subtraction property says if you have 2 things that are set equal to each other that you could subtract the same thing from both sides. So I could go about this and say I could subtract 4 from both sides. Okay. The multiplication property says you can multiply both sides by the same thing, and division property says you can divide both sides by the same thing. Okay. The substitution property is probably new to you. That one simply says that if you have 2 things that are equal, that you can replace them with each other in an expression. An example of this would be if I knew that 3x equaled 12, but excuse me, that's not what I want to do. Sorry, my bad. Boy, this technology does not want to work today. Let's start over with that. This video does not want to go today. Okay. No. For example, if I knew that I had the expression 3x plus 7. Okay. And I knew that my value of x was 4. Then I could use the substitution property and take out the x in this expression and plug in the number 4 for it. So I could rewrite it as 3 times 4 plus 7. That's an example of the substitution property. Taking 2 things that are equal to each other and replacing one with the other in another expression. The transitive property works a lot like the law of syllogism that we used in the previous section. It says if you have 2 things that are equal to each other, but then that second one is equal to something completely different, then the first and third have to be equal to each other. A good mathematical expression for that would be, for example, I have 2x equals 10, but 3y also equals 10. Okay? Notice that two things are both equal to the same thing. This would be our b values because they match. Okay? So then the transitive property says if you have two things that are equal to the same thing, then they would also be equal to each other. So you could rewrite this problem and say, well, then 2x has to be equal to 3y. The reflexive property simply says that something is equal to itself, so it would say 3 equals 3. We'll talk a little bit about the reflexive property. It's not high on our priority list. You will see where it comes in handy in a couple of problems, but it's really just something equals itself. And the symmetric property is what allows you to rearrange the sides of the equation. I know a lot of you have problems with if you get down to an answer in an algebra problem and you know that 3 equals x. That bothers you. You'd rather write x equals 3. Okay? It's the symmetric property. That's what allows you to do that. It allows you to flip the two sides of the equal sign. And the distributive property, just a quick review, we know that the distributive property allows you to take a multiplied value from outside the parentheses and push it through the inside of the parentheses as long as you multiply it by everything. All right. We've talked about the segment addition postulate and angle addition postulate in past sections. If you need to review those, you probably should go back and do that. They should be in, I believe, section 1.5 and 1.6. That's what allows you to say that two segments go together to make a bigger segment or two angles go together to make a bigger angle. Okay, so here's some example problems. If I asked you to, which property from the previous page says that the measure of angle z equals the measure of angle z? How do I know that? How do I know that something is equal to itself? Which property allows me to do that? That would be the reflexive property. Okay. What about here I have if 2x plus y equals 5, and I know that x equals y, then I can rewrite that by saying 2x plus x equals 5. Notice my y disappeared and I replaced it with an x. Why did I do that? Because I could substitute. That's the substitution property that allowed me to take out the y and replace it with an x. If 8x equals 56, then x equals 7. What did I do? What changed? I divided both sides by 8. So since I divided both sides by the same thing, that's the division property. And here, if I know that angle 1 is congruent to angle 2, but angle 2 is also congruent to angle 3, then how do I know that 1 equals 3? That would be the transitive property. Okay. All right, in this example problem, it says they want you to use the symmetric property to rewrite this statement. Okay, the symmetric property says that you can flip the two sides of the equal sign. So if I was going to do the symmetric property on this statement, I would write then that angle K is congruent to angle H. All I did was flip the two sides of the equal sign. Okay. The subtraction property on this, what might I want to subtract from both sides? The 6. You'd want to subtract the 6 from both sides. So I would minus 6 and minus 6, and my new statement would read 5x equals 15. That's how I would use the subtraction property. I would go to 5x equals 15. Okay, if I want to use the distributive property, in this problem, that means I'm going to take that 3 and I'm going to multiply it by the things that are inside the parentheses. So I would rewrite that problem as 3x plus 12 equals 12. Okay. Definitions, recall your definitions from chapter 1 because there was lots of them. If 1 and 2 are supplementary, then what do I know? Well, then I would know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, because that's what the definition of supplementary is. that two angles add up to 180 degrees. So that's how I would use a definition, just like I would use a property. Okay. Using the definition of bisect, remember bisect means to cut into two equal parts. So if I have a segment, if I have a ray AB that bisects angle CAD, and you could easily draw yourself a picture if you need to. So you've got CAD, and then you've got a ray AB that bisects it. Okay, bisect means to cut in half, two equal parts. So what would the two equal parts be? That would be angle CAB would have to be equal to or congruent to angle, and you could either call it BAD or DAB. Either one. That would be using the definition of bisect. Okay, that concludes this lesson. The homework is as follows.